Hello, good evening to all of you.
Good evening, sir. Good evening, sir.
Good evening, sir. Namaste, sir. Good evening, sir.
Am I audible?
Yes, sir. Yes, sir.
Okay, fine. Could you please mute your mic? Okay. Is my screen visible to you?
Yes, sir.
Okay, thank you. Let us get started. Please answer your attendance. Aditya Kumar. Anand.
Yes, sir.
Anand Kumar.
Yes, sir.
Sir, Aditya is present, sir.
Okay. Arnachalam.
Present, sir.
Hasan.
Present, sir.
Hemant.
Present, sir.
Jagan.
Yes, sir.
Kesav Prasad.
Yes, sir.
Lakshmi Narayanan.
Present, sir.
Prabhakaran.
Present, sir.
Prem Vinayak.
Present, sir.
Rahul. Roshan Kumar.
Present, sir.
Sabish Kumar.
Present, sir.
Satish Kumar.
Present, sir.
Titus.
Present, sir.
Valish. Vigneshwaran.
Present, sir.
Vijayaraj.
Present, sir.
Vikash.
Present, sir.
Vivekanand.
Present, sir.
Yadav.
Present, sir.
Yuvaraj.
Present, sir.
Okay. Today there are two absentees, Valish and Rahul. Okay, welcome back to this course on IC engine combustion and pollution. So in the previous class, we were discussing about the effect of molecular structure of hydrocarbons on CI engine combustion. So previously we discussed about the molecular composition of gasoline and diesel. So this gasoline and diesel are the primary fuels that we use in internal combustion engine, gasoline for spark ignited engine and diesel in compression ignited engine. So we have discussed that these two fuels play a dominant role because of the distinct characteristic they possess, okay, which make them unreplaceable. After that, we have discussed how crude oil, which is a source for this two fuel, is processed to get gasoline and diesel. Then we discuss molecular composition of gasoline and diesel, followed by a discussion on the effect of molecular structure of hydrocarbon present in gasoline and diesel on the combustion characteristic. So in the previous class, we were discussing about this effect of molecular structure of hydrocarbon on CI engine combustion. So we use two important combustion parameters. One is ignition delay time, other one is duration of combustion. We have discussed how the hydrocarbon molecular structure. So we know that there are only 5 distinct molecular structure of hydrocarbon present in gasoline and diesel. So we have discussed how these 5 different molecular structure hydrocarbon affect delay time, ignition delay time in terms of cetane number. So this different molecular structure hydrocarbons have different cetane number, okay, and we have seen that the variations in the molecular structure significantly varies the cetane number, and thereby it varies the delay time, ignition delay time. There is an inverse relationship. The most important takeaway here is below a cetane number of 40, there is a sharp increase in the ignition delay time, which we don't want to happen in an engine, which may lead to very high combustion noise and eventually the damage to the engine. So this is one of the important property that needs to be looked at, cetane number. which is a measure of ignition quality, and that is primarily dependent on the molecular structure of hydrocarbon present in diesel fuel. So we also have seen that based on the delay time variation, the duration of combustion is also varies. It's like an inverse relation, as you could see, linearly correlated, combustion duration and delay time linearly correlated, and it's an inverse relation, meaning high or long ignition delay will lead to shorter combustion duration. It's almost like a instantaneous combustion or constant volume combustion. When you have a longer delay, again, we don't want that to happen because it will damage the engine for the same reason, whatever I said just now. So we want a progressive combustion, and I discussed this with thermodynamic cycles, auto, diesel, and dual cycle in the previous cycle. So in the previous class, so we want the diesel engine combustion is typically approximated as dual cycle, which include instantaneous constant volume heat addition as well as constant pressure heat addition. In fact, we want more constant pressure heat addition, which is a progressive or slower combustion phase, diffusion phase combustion. Later on, we will discuss more about this different stages of combustion. But the focus, our focus here is to see how the hydrocarbon molecular structure affect delay time, and thereby it affects the duration of combustion. We have also seen that in a particular molecular structure, the variations in the carbon chain length will also affect the delay time. An increase in carbon chain length increases tendency of forming radical because you have more carbon and hydrogen atom. Longer the chain length, more tendency to form radical will be there, and because of that, the delay time drops because ignition quality improves with the increase in carbon chain length. We have also seen that the delay time has two elements, chemical delay and physical delay. Physical delay has to do with forming ignitable mixture, and chemical delay has to do with forming radical from a stable molecular structure. So we have discussed how these two ignition delay time, physical and chemical delay time, vary based on molecular structure. Here you have three different molecular structure: hydrocarbon, normal paraffin, olefin, and cycloparaffin. So if you have normal paraffin or olefin, the chemical and physical delay times are comparable. They are almost of same equal split. But when you look at cycloparaffin class, the physical delay time is less, chemical delay time is considerably high. So what it conveys to us is when you have a stable molecular structure, then the overall delay time is influenced more by chemical delay rather than physical delay. Okay, this is what is happening in an actual engine also. I already said this. Overall ignition delay time is more influenced by chemical delay rather than physical delay. Why? Because we have a better in-cylinder conditions at the time of fuel injection. So we may end up in forming ignitable mixture quickly, but it may take more time to form radical from the stable molecular structure. This is the meaning of that, especially when your fuel composition include more stable molecular structure hydrocarbon. The delay time is primarily influenced by chemical delay rather than physical delay. Today we are going to start with our discussion on how the molecular structure of hydrocarbon affect SI engine combustion. Similar to CI engine combustion, spark ignited engine combustion is also influenced by variations in the molecular structure of hydrocarbon. Okay, so here the primary effect is through variations in the antenna quality. Based on hydrocarbon molecular structure, the antenna quality is going to be different. And this antenna quality is measured in terms of a property called octane number, similar to cetane number that we use for CI engine. There is a measurable property octane number that we use in spark ignited engine. Okay, this is considered as a measure of antenna quality of the fuel. Based on variations in the hydrocarbon molecular structure, this antenna quality is going to be different. That will reflect in different octane number. Okay, so do we want a higher octane fuel or a lower octane fuel for SI engine application?
Sir, higher octane.
We want higher octane fuel because we want fuel that resists self-ignition. Okay, antenna quality is a measure of how the fuel resists self-ignition. The fuel should not self-ignite in a spark-ignited engine. I will discuss more about the combustion phenomena later on. But here, just take a note that when you discharge electric spark, you are forming a flame, stable flame. The flame has to move across the combustion chamber and the flame has to ignite the mixture. At any point of time, fuel air mixture should not self-ignite. Self-ignition of fuel air mixture is what is leading to knocking combustion, which will translate into combustion noise, and very intense knock will damage the engine. We don't want that to happen. So the primary requirement from the fuel perspective is it should resist self-ignition. That is defined in terms of antenna quality, measured in terms of octane number. So I prefer to have fuel with a high octane number in order to have a smoother engine combustion without any high combustion noise or engine damage. This is what I expect from the fuel, and this characteristic are significantly influenced by the molecular structure of the hydrocarbon. So we have discussed the 5 different hydrocarbon molecular structure, okay, and we have already discussed how this 5 different molecular structure affects ignition quality in terms of C10 number. This discussion we already had. You have these 5 different molecular structure, and C10 number is significantly different. C10 number in normal paraffin is high, meaning better ignition quality. C10 number of aromatics is very low, meaning poor ignition quality. And we know that ignition quality and antenna quality are inversely proportional. So here Cn is C10 number, On is octane number. These two are inversely proportional, and C10 number is a measure of ignition quality of the fuel. Octane number is a measure of antenna quality of the fuel. So these two have an inverse relationship, meaning if I have a fuel with high C10 number, if I have a fuel with a high C10 number, then octane number is going to be less. So what I want for SI engine application, I want fuel with a high octane number, meaning the C10 number should be less, or in other words, the ignition quality should be poor. Then only you will have a better antenna quality. This is what you want for SI engine application. So the variations in molecular structure of hydrocarbons significantly affects this antenna quality. Okay. So now with that background information, now we are looking at how the octane number is going to be different for different hydrocarbon classes. So here I have included 4 classes: normal hexane, this is a normal paraffin class, this is olefin class, this is cycloparaffin class, and this last one is benzene, which is an aromatic class. So you have 4 different hydrocarbon classes. This is a molecular formula, molecular structure, and RON is research octane number. I'll talk about this research octane number later on. There are 2 octane number. One is research octane number, other one is motor octane number. Okay, so here I have included research octane number. So we are looking at how this research octane number is different, how this research octane number is different, or how it varies with the hydrocarbon molecular structure. So when you have a normal paraffin class, okay, you have a very low research octane number. This is 25. Can you tell me why?
So no double bonds.
Yeah, this is a chain-like structure. It's having high C10 number, right? This is what we discussed earlier. High C10 number will reflect in low octane number, inversely proportional. Okay, so you have a very low research octane number value here. Now you look at the benzene, which is an aromatic class. The octane number is 123. Within bracket, it is given that it's estimated. So you can measure up to 100. Above 100 is an estimated value. You have to do extrapolation. Later on, I will talk about octane number measurement. Okay, here just take a note that the value, octane value, is very high for this hydrocarbon molecular structure, which is an aromatic ring with a double bond. Very stable molecular structure that has a very high octane number. In other words, very poor ignition quality. This is what we already discussed. Now, the normal paraffin, which is having better ignition quality, has very poor antenna quality reflected in very low octane number. So now you have these 2 extreme cases. Now you have these 2 extreme cases, 125 and the other one is 123. For olefin and cycloparaffin, you have values in between. Okay, so this is lower bound, this is upper bound, and in between you have this olefin class and cycloparaffin class. So the takeaway, important takeaway for you is based on hydrocarbon molecular structure, research octane number, which is a measure of antenna quality, is significantly different. It can vary anywhere between 25 and 123. And if you have to use a fuel for SI engine application, we need to have some minimum octane number. Otherwise, we should not use. Similar to minimum C10 number requirement for CI engine, here we have a minimum octane number requirement for SI engine application. Otherwise, you will end up in having combustion noise, and the worst case scenario is engine damage. Okay, so we now understood that the hydrocarbon molecular structure has a significant effect on the antenna quality of the fuel, quantified in terms of research octane number. What is interesting for you is the second row, which is given the bottom. Okay, what we are observing in the second row is if you attach alkyl side chain, methyl side chain is what is attached to this base structure. If you consider this 4 as a base structure, what we have done here, we are adding side chain. You could see here that there are 3 CH3 group, 2 CH3 group attached to the second carbon atom, and 1 CH3 group attached to the fourth carbon atom. So by adding this alkyl side chain group, you could see that the research octane number is increased from 25 to 100. So what is happening here, based on whatever discussions we had so far, can you comment on this? Why research octane number is increased by adding? So what we have done is we have considered this as a base structure and added 3 CH3 group to this base structure. By doing this, the octane number is increased from 25 to 100.
So because branching has branching of the stability of the fuel in that sense of the compound.
Yes, yes. When you do branching, stability of the fuel is increased. In other words, the tendency to form radical decreases. In other words, the ignition quality drops. When I say ignition quality drops, antenna quality improves, reflected in an increase in octane number from 25 to 100. Now, what is this hydrocarbon class with a branched structure?
It's methane, sir, CS3.
Now, what is this hydrocarbon class? We have only 5 classes, right? This is normal paraffin. To the normal paraffin, an alkyl side chain, 3 side chains are attached. And what is this class, hydrocarbon class, the one in the bottom, this one?
Yes, sir.
What is it?
Olefins.
Sir, isoparaffin.
Isoparaffin. Isoparaffin is having a branched structure, right? So this
Yes,
is
sir.
This is isoparaffin. So we earlier discussed about refinery processes, right? Can anyone tell me what is the refinery process that will do this? There is a refinery process that can convert normal paraffin to isoparaffin by adding alkyl side chain.
Sir, hydro, you're told that if we pass, make it react with hydrogen, it can happen. If I'm not
So that is the hydro treatment. Hydro treatment is done to remove sulfur and nitrogen from the.
Oh, I'm sorry.
Yeah.
Memory is misplaced. I'm sorry, sir.
So here I'm modifying molecular structure from normal paraffin to isoparaffin, and there is a process involved, refinery process involved. In fact, they do this to improve the antenna quality of gasoline.
Sir, is it cooking or?
This is catalytic reforming. If you relook at our material, whatever we discussed earlier about refinery processes, this particular process is called catalytic reforming. Catalytic reforming is done to modify the molecular structure. Okay, in this case, it is modified from normal paraffin structure to isoparaffin structure. This is primarily done to improve the antenna quality of gasoline. This is one of the important refinery process that is being done. Here, another important information for you is, you know that gasoline or petrol price is always high compared to diesel. Have you wondered why? Both are from crude oil reserve, both are from crude oil source, but gasoline price is always high compared to
Sir,
diesel.
you had told that the process required for producing the gasoline is much more compared to the
Yes,
petrol.
it's more process intensive. The number of refinery process that needs to be carried out to produce gasoline with the required quality, fuel quality is much higher compared to diesel. So it is more refinery intensive process for getting gasoline or petrol. That's why the cost of petrol or gasoline is always high compared to the cost of diesel fuel. Diesel is less refinery intensive, whereas gasoline is more refinery intensive. Meaning, if you have to produce gasoline with the required well-laid specifications, fuel specification, then the number of process that needs to be carried out is very high. That's why you have a high cost. You are paying more for gasoline as compared to diesel. And one of the important process that is being done in the refinery to get gasoline is this catalytic reforming. What they do is they convert more of normal paraffin structure into isoparaffin structure because they want octane number to be increased. Okay, here in this case, the typical numbers are given 25 to 100. Now you observe what is happening to adding alkyl side chain to the olefin class. So hexene is a olefin. By adding same three methyl group, you could see that octane number is increased from 76 to 106. Again, by doing branching, you are improving antenna quality because ignition quality drops when you do branching. It's a kind of stable structure compared to chain. Okay, but the increase is not significant because you already have a double bond. In the first case, you don't have a double bond, all are single bond. By doing branching, there is a significant increase in antenna quality. The second case, it is not so. Now look at case 3, cyclohexane, which is a cycloparaffin class. Here you are adding 2 methyl groups. What is happening to octane number? From 83, it has dropped to 72. Again, the fourth one, benzene, which is an aromatic class, ring with a double bond, that is what is aromatic. By adding 2 methyl groups, you could see that octane number drops from 123 to 118. So for case 3 and case 4, there is a drop in octane number, right? For case 3 and case 4, there is a drop in octane number. For case 1 and case 2, there is an increase in octane number. Can anyone tell me why for case 3 and case 4, there is a drop in octane number?
So it's basically a ring structure which is more stable. When you add a branch to it, it becomes weaker actually from that branch
Exactly.
itself.
Perfect answer. So this structure is more stable, both ring with or without double bond, it is more stable. You have a high octane number because ignition quality is poor and antenna quality is better with this kind of structure. Now, once you start adding this methyl side chain, you can initiate radical formation from the methyl side chain rather than the base ring, which is very stable. Okay, so radical formation tendency increases by adding alkyl side chain to these 2 hydrocarbon. Did you understand? Radical formation tendency increases. In other words, ignition quality improves if you add alkyl side chain to cycloparaffin or aromatic class. So to these 2 classes, if you add this side chain, you are actually improving ignition quality because you can initiate radical formation from the side chain. Base structure is very stable. You have to provide more energy to form radical from this, but this is weak. By adding this, you are initiating radical formation from this, meaning you are improving ignition quality. In other words, antenna quality drops. That reflects in a drop in octane number from 123 to 118, 83 to 72. Whereas for the first 2 cases, if you add alkyl side chain, the structure is becoming more stable. So radical formation is difficult when you add side chain to this normal paraffin or olefin. That's why you have an improvement in the octane number, especially for case 1, which is a normal paraffin class. You are converting that into isoparaffin through this catalytic reforming that significantly improves octane number. Okay, this is what our refinery do to improve the antenna quality of gasoline. Okay, so our understanding, the takeaway for you here is hydrocarbon molecular structure significantly affect the antenna quality reflected in the measured property octane number. Okay, so now you have an improved understanding of what effect molecular structure has on the octane number or antenna quality. Now accordingly, you will be able to comment on what kind of composition we need to have for gasoline. If you want to improve antenna quality, what you need to do also you now understood. Okay, so you can carry out these kind of processes in order to improve the antenna quality. So it is doable, right? If you have a base crude oil with a particular composition, you can refine it, you can carry out these kind of processes so as to improve the antenna quality of gasoline. So this is the last topic before I close this chapter 1. Now we have come to the last topic in this chapter 1, which is about fuel properties. So we are here, we are going to discuss about this important fuel property. So far we have discussed about these topics in this chapter 1. The primary focus of this particular chapter is to understand the composition and molecular structure of gasoline and diesel, which we use in SI engine and CI engine. This is very important to know from the combustion perspective. Okay, so before, so we have so far discussed about that. Before I close this chapter, I'm going to discuss about some other important properties of gasoline and diesel, which are relevant for spark ignited and compression ignited engine applications. So you have two tables here. The first one is showing up the properties of gasoline relevant for spark ignited engine application. Second table shows the properties of diesel relevant for compression ignition engine application. In each table, you have 3 columns. The first column shows important properties. Second column shows the effect of these properties on SI engine. And the third column shows the BS6 value. What is this BS6 value? Any idea? So here you have some numbers or limits, and that is specified as BS6 value. What is this?
Is Bharat cycle emission, sir? Emission
yeah, so that is for pollutant emission. Now, what is this BS6 for fuel?
Reference fuel, sir.
Oh, reference fuel. So here we have some numbers under this. Can I say that this is a specification, fuel specification? BS6 is the fuel specification. So I think I already told you that based on the emission norms, the fuel quality also should be modified. Like emission standard, you also have fuel specification standard. So there is a group, statutory group, right, available in each country to ensure that the fuel produced from refinery is of a recommended quality. The fuel that we get from the market, which are legally sold in the market, should comply with certain specifications. Okay, there is a legal requirement for fuel quality also, similar to legal requirement for pollutant emission from the engine tailpipe. There is also a legal requirement for fuel specifications. So fuel that are produced by the refinery should comply with this. So you could see that there is a minimum octane number being specified by this. Any fuel sold in the market, okay, in the pumping station should comply with this. Okay, this is where the refinery processes, as I just now said, that for gasoline it is more intensive because they have to produce octane number with a minimum value of 91. Okay, and this is significantly influenced by hydrocarbon composition and structure, which is what we have discussed so far. Okay, so these specification agencies, fuel specification agency, set the limit for important fuel property. That limit only we are seeing here. They also specify how the property should be measured. They lay down the testing procedure, property measurement procedure. They lay down what kind of equipment that you need to use, and they also set the limit for the property. This is to ensure that the fuel available in the market is having the required standard quality. So you know that the engine technology and fuel should go hand to hand. The refineries, in fact, discuss with engine OEM and they arrive at this specification. So I discuss about American and European diesel fuel, right? Crude oil available in America is having a very high aromatic content. That's why the fuel has a cetane number of 40, which is a lower bound. And we know that below 40, you will have a very sharp increase in ignition delay. So the fuel with such a poor quality is taken care by engine technology. Okay. So the point for you is similar to emission norm, there is a legal norm set by fuel specification agency. Those legal limits are only we are looking at here. When you go to pumping station, any pumping station, they should show you the density of the gasoline and diesel. Have you ever looked at it? This is one of the legal requirement.
Yes, sir. There is a small window
Yes,
near
yes.
that.
That should, show you the density value. This is an important requirement. You should watch out, because when they mix gasoline with some adulter, right, some other component, you won't be able to meet these legal specifications. Okay, so it may drop below this. If you drop below this, there are several effects. I will discuss about this. Okay, so these are some legal requirement. Who is setting this legal requirement in India? So we have, just now I said that we have a fuel specification standards. We have a fuel specification standard.
Sorry, can I ask a question, sir, if you allow, sir?
Yeah.
Please?
Yes.
In the table, there is no mention of flash value of petrol, gasoline.
Mm-hmm.
So, what is the indication of what is the hidden?
Meaning that they have not laid down any limit, legal limit for flash point temperature.
And generally, that you have
Anything
told is
missing-
-45. If I'm not wrong,
missing
right?
here, if any number is missing here, it means that according to the legal specification, those are not specified.
But typical value you had suggested in the past was around -45 degree. If I'm not
Yes,
wrong, right?
yes, yeah, it is too low.
Okay, sir. Thank you, sir. Thank you so much.
Yeah, yeah.
Sir, one more clarification that RON and MON. RON is mentioned that research octane number. That MON,
Yes.
can you?
MON is motor octane number. I'm going to give you more detail about this two number. It is based on how we are measuring octane number. Based on the measurement method, you have two numbers.
Thank you, sir.
Sir,
Yeah, MON is motor octane number. Yes.
this fluid density you have mentioned was the density 15 degree, 720 kg per meter.
Yes.
If temperature increases, maybe Rajasthan, some area temperature will be 50, some area it will be below 10.5. So that time it will density will increase or decrease?
Density with higher temperature, density will drop. But for liquid, the drop in density with temperature is minimal. The changes density, liquid is an incompressible fluid, right? Unlike gases are compressible fluid. For gases, the density variation with temperature is so high. For liquid, it is minimal. There is a minimal variation.
Okay. Because you told us that this is easily evaporative compared to diesel, petrol.
Yeah, when the temperature varies, boiling range, whatever fuel evaporate is based on the boiling range. Okay, that has nothing to do with the density. Density is the mass per unit volume. But that is also dependent on temperature. But what I am saying here is for liquid, the variation in density with variation in temperature is very less compared to gases.
Okay, sir.
Okay. So there are specification agencies in India. There are a group of fuel specification agencies. Some of them I have highlighted here: Indian Institute of Petroleum, Dehradun; Indian Oil Corporation, Faridabad. These are the fuel specification setting agencies. Likewise, you have other agencies set up by the government of India, and they are taking care of the fuel, whatever limits you have seen, BS6 limit. They are being set by these specification agencies. Okay, so there is a group of statutory organizations set up by the government to ensure that the fuel that are sold in the market complies with some legal limits. Okay, that is what you are seeing there as a BS6. Now we have BS6 norms, emission norms from April 2020. Similarly, the fuel that we are using in the vehicle should also be a BS6 fuel. Okay. So what this specification agency, when they set the limit or when they lay down the procedure for measuring property, what is the objective behind all those? Those are highlighted here. The specification agencies have to ensure that the fuel that is available in the market has certain quality so that these requirements are met. So I have laid down some important requirement that needs to be met based on the fuel quality, and this is what our specification agencies are looking at. They check the quality of the fuel to ensure that all these are met. The engine start quickly without any cold start problem. This is more severe in SI engine application. I will talk more about it later on. But we need to ensure that the engine start without any problem, especially under cold weather conditions. Actually, in Western countries, it's a more severe problem compared to our country, which is a tropical country. The surrounding ambient temperature is always high. Okay, so these legal specification agencies check the fuel quality, ensure that the engine start without any problem, especially without any cold start problem. This is one of the requirement. Better acceleration response. Okay, acceleration response, as you know, as soon as you press the acceleration pedal, what we expect from the vehicle is it needs to provide higher torque, higher power in no time. We want immediate response. Okay, that again depends on the fuel characteristic. There are engine technology will also play a role, but fuel has a significant role to play in affecting the acceleration response. Okay, so they will ensure that the fuel has the required quality so as to have better acceleration response. Engine delivers the required torque and power. So the fuel has should have the required energy content so that the power and torque requirements are met. Engine runs smoothly without any combustion noise. So we have already discussed how the combustion noise will be affected by the molecular structure of hydrocarbon present in gasoline and diesel. So these legal agencies will ensure that the fuel has the required quality so that the engine runs smoothly without any noise. For example, in a CA engine, if the delay time is more, you're going to get more noise, meaning it should have the C10 number, required C10 number. It cannot be too low. It will lead to high noise. So this is what they are checking. Then better fuel economy or mileage. This is again an important requirement, and it depends on the quality of the fuel. Lower pollutant emission. So we need to now meet BS6 from April 2020. Fuel has a significant role to play. So fuel quality should be ensured so that you could be able to meet this pollutant emission. Otherwise, whatever engine technology upgradation you do, if the fuel doesn't have the required quality, you won't be able to meet the legal limit. Longer durability or life. So you know that IC engines, one of the reasons why IC engines are popular for more than 100 years, why we cannot get rid of IC engine with EV is the primary reason is the durability or life of IC engine vehicles are high. What is the typical life of IC engine vehicle? Can you comment?
So for two-wheeler, it's around 1 lakh kilometer. For four-wheeler, it's around.
No, in terms of year period.
So
Around 15 years, sir.
yes, sir.
15 years, 10 to 15 years, right? On an average. So the IC engines are known for durability, right? They are durable, and because of this, they are popular. This is one of the important reasons. Two reasons: one is fuel economy, and second one is durability. Okay, typical lifetime is well about 10 years. Okay, for the vehicle. Because of that, they are popular, and durability is also affected by the quality of the fuel. If you use substandard fuel, the durability is going to come down because the components you need frequent replacement of component. The fuel quality plays a significant role in the life of the vehicle. Okay.
Sir, one question.
Yeah.
Currently, if some customer is having BS3 vehicle, he is using that vehicle was developed with reference fuel of BS3. So BS4, BS5, BS6 currently coming. If he is using BS6, currently he is using currently if he is using that vehicle means he has to use BS6 diesel or BS6 petrol. So this fuel will affect that any performance. I mean, in the combustion, in the aspects of combustion.
No. So the only thing is you should not use a substandard quality, fuel quality, right? So when you talk about BS3 and BS6, BS6 quality is upgraded, right?
Correct, sir. Correct.
Engine technology is not upgraded, but fuel is upgraded. If you use upgraded or high quality fuel, there is no effect. I mean, there is no negative effect.
Okay.
It's not a problem. You can use BS6 fuel in BS3 vehicle, but you should not use BS3 fuel in BS6 vehicle. This is what I want to say.
Okay, sir. Thank you.
Okay.
Question. Hello, sir.
Hello? Yeah.
Sir, like for colder region, we need to add some additives for better stability. So for countries like India, where we have a different kind of climate conditions, like if we go to totally northern part of it, India, we have colder regions. But once we come down, we do not have that problem. So is it suggestible to have two kind of fuels with some additives to maybe to save on some cost or some other benefit?
Yeah. So you need to use additive definitely. And as I said, in Western countries, you need to use some starting aid also. You need to have an intake heating system. Okay, and there are some additive like cold flow improver additive, because fluidity will, I'm going to talk about that in diesel property, which is defined by this CFPP. Okay, the fluidity of the fuel gets affected based on the surrounding ambient temperature. Okay, to improve that, you may have to use some additive, otherwise the fuel won't even flow. When the fuel doesn't flow, the engine won't start. Okay, so you have to use additive. Point number one. Point number two, you may also have to use these additives are generally used in smaller quantities. Sometimes you may have to use additive under external aid. For example, you have to use a glow plug to start the engine. You may have to use intake air heating system also. So based on the prevailing surrounding temperature, the call on additional technologies and the additional requirement for the fuel are made.
Okay, sir. Sir, one thing I want to understand on this, like how much impact, if it is done, like for making two separate fuels, how much impact will it give on the cost if we decide the fuel for non sub-zero regions, like for warmer regions?
It's more of on the spot decision because it depends on the ambient temperature. So they will study ambient temperature, and in fact, that will make you to take a call on how much additive you need to use and how much of additional technology you need to use. So all these have to be made on the spot based on the prevailing temperature. What I mean to say here is it is not constant, it's going to be a variable. But cost will play a primary role. It will be at the forefront before you fix a particular technology.
Yes. So means how much cost difference will it give? Means if we compare a fuel for colder region and we have another fuel for means higher temperature region. So how much will be the cost difference?
No, that's what I'm saying. It's very difficult to give the number here. You're asking about the difference in cost. It's very difficult to give the number here because, as I said, the decision has to be made on the spot. How much of additive I need to add, whether I need to add any additional engine technology, I need to take a call based on the surrounding ambient temperature. For example, in Western countries, they will definitely have a starting aid. They will definitely have a heating system. Otherwise, the engine won't start. Engine won't start. Okay. Here in India, northeast state will have a very low temperature. Again, this temperature, ambient temperature is a variable. Okay. Based on that variable, you have to fix additive quantity. You have to take a call on whether we need additional engine technology.
Understood, sir.
Okay.
Sir, query, sir, in compressed natural gas, the hydrocarbon length is very simple compared to petrol. Still, it is having a octane number is around 120. How it is possible in methane? Because hydrocarbon length is very simple, CH4. Still, it is having more octane number compared to petrol. So how?
See, hydrocarbon, so you are talking about gaseous fuel, compressed natural gas. Compressed natural gas has only one carbon, right?
Yes,
so
sir, yes.
Here you should understand that when the number of carbon atom, that is what we have seen here. I will show you. This we have already discussed. Based on the carbon chain length, you see the delay time is going to be different. When the carbon chain length, see here it starts with 5. Now you're talking about methane. Methane, how many carbons are there? Only 1.
Yes.
You see how the ignition delay is varying with the carbon chain length. When you have less number of carbon, the delay time is increasing. In other words, the octane number is increasing.
Okay, sir. Okay, sir.
Only with the larger carbon chain length, gasoline is coming here, right, around C9. We have discussed carbon distribution. Diesel C14 to C80, it is coming here. So delay is too short. CT number is high. Okay, so here, based on the carbon chain length of the different hydrocarbon, the octane number is going to be different. Even if it is a normal paraffin class, if carbon is 1, it is going to have a long delay, meaning high octane number.
Okay, okay, sir. Thank you.
Okay. So here we are looking at how the properties, what are the important properties, how it affects engine characteristic, and what is the BS6 value for the associated property. Okay. Octane number and volatility are important fuel characteristic. I will give more detail in the subsequent slide. Next, we are looking at density here. Density affect fuel economy. I think we have already discussed about this. Density is mass per volume. When you density is defined as mass per volume. Our system meters fuel on volume basis. So this is fixed as constant. You are allowing a constant volume of fuel based on the engine operating condition. But based on variations in density, if the density is high for the fuel, the mass is going to be high. If density for the fuel is low, the mass is going to be less. Combustion energy release is a function of mass of the fuel that goes into the cylinder and the heating value, which is the next parameter we are going to see. So if you have a fuel with high density, it is advantageous because more mass goes into the engine cylinder, meaning the energy release will be high. Or in other words, if you have a high density fuel, it is enough to consume less quantity of fuel. So that will reflect in better fuel economy. High density fuel will cause better fuel economy. Okay. So it is preferable to have higher density because fuel economy will improve. This is one of the reasons why diesel engine fuel economy is always high compared to gasoline engine. You could see that the density here is 810, here it is 720. Diesel is a high density fuel. This is one of the reasons why the mileage is better with a diesel vehicle compared to gasoline vehicle. I'm comparing similar engine capacity, okay, and rated power. Diesel is beneficial because it's a high density fuel. So you will have better fuel economy and mileage if you have a high density fuel, but you will have other problem. There is an upper limit. You should not increase density beyond 775. That is upper limit, legal limit. Otherwise, it will lead to these two problems. One is oil dilution. Other one is CC deposit. CC is combustion chamber deposit. Inside the combustion chamber, you will have a deposit. The deposits are primarily soot particle, black soot particle. You will have more soot particle if you have a high density fuel. So what is happening is when the density of the gasoline is high, it will become heavy. So when you have a heavy fuel, heavy gasoline fuel, it will take longer time for vaporization. So it will stay in the liquid phase for a longer time. Once gasoline stays in the liquid phase for a longer period, it is going to dilute the lubricating oil. You know, an engine has a separate lubrication system that provides lubricating oil to different components, including engine components like piston and liner and so on. So you have generally a boundary, especially between piston and liner, there is a boundary lubrication regime. You will have a thin film of lubricating oil present closer to the liner. Once the fuel stays in the liquid phase for a long blend with the lubricating oil. Fuel is a hydrocarbon. Lubricating oil is also a hydrocarbon. But what is the difference between these two?
So oil is more viscous and fuel is less viscous in that sense.
Lubricating oil is more viscous. It's a heavy hydrocarbon. It's more viscous. Okay, once the liquid phase fuel goes and blend with the lubricant, these two will blend nicely because both are hydrocarbon. There is no miscibility issue. So the liquid phase fuel will go and blend with the lubricating oil, which is thick and viscous. That is what you want for a lubricating oil because it has to prevent the metal to metal contact by forming a film and thereby reducing the wear rate. Okay, friction and wear rate needs to be reduced. This will directly affect the durability of the components, isn't it? So that is the reason why we have a separate lubrication system. When the fuel is high density fuel, it will stay in the liquid phase for longer time. Because of that, it will go and blend with the lube oil, especially lube oil film that are available around the liner region. Once it happens, the oil will lose its viscosity. The oil will lose its lubricating property because now it is diluted. This is what I mean by lube oil dilution. Once the oil is diluted, its viscosity will drop. You know, once the oil viscosity drops, it will lose its property, lubricating property. Eventually, it will reflect in a very high wear rate of the component, and ultimately, it will lead to failure of the component. Okay, that is a worst case scenario. So we should not use high density fuel. There is a limit. That's why we have upper limit. Otherwise, the fuel will be in the liquid phase for longer time. When the fuel vaporizes, once it goes into gas phase, it is not a problem. But once the fuel stays in the liquid phase for a longer period, it is going to blend with the lube oil. It will affect the wear and tear. It will increase wear and tear of the engine. This is what I mean by oil dilution. Similarly, when oil and lube oil blends, it is going to participate in the combustion, right? The fuel will burn along with the oil. That will lead to very high combustion chamber deposit. That is what is CC deposit. So heavy fuel will cause this two problem. It will dilute the oil, it will burn with oil and increase the deposit formation in the engine. That's why you have a legal upper limit 775. We should not use heavier fuel or spark ignited engine. Then you have heating value, which is a measure of energy release. You know, heating value is expressed in terms of megajoule per kg or megajoule per meter cube. Since we store fuel on volume basis and meter fuel on volume basis, let us take the second unit. So here, in terms of heating value, we are talking about what is the thermal energy released by burning a unit volume of the fuel. Is it preferable to have a higher value or lower value?
Higher, sir.
It is preferable to have a higher heating value because once you have a higher heating value, you will get more thermal energy release. Eventually, it will result in conversion of more work. You can produce more power or work. Okay, if you have a high heating value fuel. How it will affect is, it will affect two things. One, it will make your fuel storage system more compact because you have a high heating value fuel, which can release more energy, meaning that it is enough to store less fuel for a given distance that is traveled. And second one, it's going to give you a better mileage because it is enough to burn less quantity of the fuel. If you have a fuel with a very low heating value, you have to burn more to get the given thermal energy. Okay, if you have a high heating value fuel, then it is enough to burn less to get the given energy release. As simple as that. Okay, so heating value also affects, I would say, fuel economy. It will also affect the compactness of your fuel supply system. If you have a high heating value fuel, it will make the system more compact. It is enough to store less quantity of the fuel. That is the effect of this. Unfortunately, legal standards do not regulate the heating value of fuel. One of the reason is gasoline and diesel generally has very high heating value. That's why they don't bother to regulate heating value of gasoline and diesel. Flashpoint we have already discussed. It has to do with safety aspects. Okay, it is a measure of how quickly a flame, momentary flame is formed in presence of an ignition source. It's also a measure of how quickly a fuel will form an ignitable mixture and get a flame once there is an ignition source available. This is very important, especially when you go and refuel your vehicle in a pumping station. There is an accidental spill you can expect. The fuel may spill out, it may form ignitable range mixture. And if there is any nearby ignition source available, a flame will form. Once the flame is formed, all the damage will be done in no time. So that's why this is an important property from the safety aspects. Gasoline and diesel are generally very safe. We already discussed about that. Gasoline flashpoint temperature is negative, diesel is positive, well above ambient temperature. So diesel will form very lean mixture which cannot ignite. Gasoline will form very rich mixture, rich fuel air mixture which cannot ignite. So both are safe fuel and there is no flashpoint temperature regulated by the standards. Okay. Aromatics is composition, it's not a property. It affects two things. We already discussed that this affects antenna quality reflected in high octane number. We prefer to have a high aromatic content so as to increase the antenna quality, but there is an upper limit. You could see 35% volume is a max limit. Okay, otherwise what will happen if you keep on increasing aromatic content? It will form more deposit because aromatics are heavier hydrocarbon. The carbon to hydrogen ratio is higher for aromatic. If you take a benzene ring, the carbon to hydrogen ratio is high, meaning the molecular weight or molar mass is high. When you have a high aromatic fuel, that will reflect in high density. Same problem, whatever we discuss here, oil dilution, combustion chamber deposit problem will happen if you have a high aromatic content in the fuel. So that's why it needs to be regulated. But on the other hand, you need aromatics to improve the antenna quality. The last one, sulfur. This is also composition. According to BS6, it's very low. Ultra low sulfur fuel is what we are using. 10 milligram per kg max. generally this affects the after treatment system. Sulfur, when it burns, it forms sulfur oxides. And sulfur oxides will affect the three-way catalytic converter. You know that. I'm going to talk about it in the second module. Three-way catalytic converter uses platinum as a catalyst, which is a noble metal, very expensive. What sulfur oxide will do is sulfur oxide will attack platinum and make it inactive. This is what is referred to as catalytic poisoning. So catalytic poisoning will happen if you have sulfur, higher sulfur in the fuel. So you may have to often replace your catalyst, which is going to be very expensive. So these are the effects of this composition and properties, important properties on SI engine. It's time up. I stop here. If you have any questions, I can take your questions. Are there any questions you have?
Sir,
Yes.
Sir,
yes.
Sir, there is a humble request from our people who is in Pune and Mumbai.
Mm-hmm.
We are ready to write the examination of Q1 and Q2 as per your scheduled time, sir. The only thing whether you can allow them to write it from the online, is it possible for us?
I think we have already discussed about this, and I said that we plan to have an in-person exam this time. And the decision is not taken by me alone. It is based on the discussion with the coordinator. Okay, actually, coordinator is what is coordinating both the courses. Okay, with both the faculty. But the decision taken at the beginning of this course is we want to have an in-person exam. Any change in this decision needs to be discussed with the coordinator and finalized. Currently, our take on this is it is an in-person exam. You may have to come to IITM to take the exam.
All 20 people will come to IIT, sir. Only the 3 people in the.
No, the problem is we cannot have both mode. This you are talking about hybrid mode, in-person and online. That will also create problem because we cannot have both simultaneously. So what you do is you can also discuss this with the coordinator, and it is better that we finalize with him in picture, right? We cannot finalize this alone.
I'm sorry to just what I mean to say is like there is a communication from institution to our HR, like what I mean to say, when we approached our HR for travel and all those things, so they have suggested that there is a communication from institute that the exam can be conducted like online also for the final semester. If you are if professor tells you to go, definitely you go. There is no problem. But for quizzes and like mid-sem, if the exams can be conducted offline also, so online also. That was the communication from management, like institute only. So basis that they have
communication from the institute. Who has communicated to you? So when you say communication from institute, what is the source? Who has sent the email?
Sir, I think it was told by course coordinator only at the end of semester in that way. And
Course coordinator, Professor Manivanan.
Right, sir.
No, that's what I said. We have discussed already. I have discussed this with Professor Manivanan, and it was decided that it can be in person. I have not received any information from him regarding the change in this stand. Okay. This is a stand taken at the beginning of the course. That is what I am communicating to you. Okay. Any change in this, he has not communicated to me. So I will have to check with him. Maybe you can also check with him and then see. But the current take on this is in-person exam. I think Professor Shankaram also would have informed about in-person exam, right? If I am right.
Shankar sir has agreed for hybrid, sir, actually, hybrid mode. Just information. Not. Okay,
so he has agreed for in-person and online both.
Right, sir.
Okay, I'm not sure whether he has discussed with Professor Manivanan, who is a coordinator. Okay. But what I will do, I will take your suggestions to him. I will discuss with him and then get back to you.
Sir, thank you so much. Okay, thank you
fine.
so much. Thanks.
Fine. Okay, anything else? So I will discuss with him. I will also inform him that for the other course, it is done in hybrid mode. We decided that we should not do hybrid or online in the beginning of the course. That is the stand taken based on discussion with coordinator. But I am not sure how the other course has changed now. I will check with him. I will also put your request to him that you people want, especially people from Pune want hybrid mode. I will put this request to him.
Only for 2 years, sir. For final exam, will come there. That's
Okay.
the only request.
Okay, I will discuss your request with him and then get back to you. Maybe in the next class. Otherwise, if I have any information, I will inform Mr. Arnachalam in between also.
Sure, sir.
Thank you so much. Thank you so much.
Thank you, sir. Thank you,
Yeah.
sir.
Thank you.
Sir, it's a request if you can share the dates as